We all know that doing regression in R is pretty easy and direct. Now, what if I tell you that doing a simple linear regression may be easy in R, but let's say I give you a data set which has multiple ways of cleavage, which means that it has different kinds of nationalities in the column country and different genders in the column gender, male and female. So essentially, if you look at this data set which you're looking in your screens, if you look at the gender column, you have two types of gender. And if you look at the nationality or country column, I have taken India, US and Australia. So three countries. So 2 cross 3, around 6 subgroups or groups you can say we have in this data, and we have an independent variable and a dependent variable. So what if we wanted to do separate regressions for these 6 different types of data or 6 different groups of data? Now you may say that why think about groups? You can just do a kind of dummy variable for your gender and dummy variables for your nationalities or country. But let's say I don't want to use dummy variable. I just want to do separate modeling for separate groups. So how do you handle that? Now, this is very important in the sense that let's say you have this kind of a data set in which you have gender, country, region and so on. Also, let's say you have a SKU level of data, or rather product category or brand level data for a company, and you want to do a separate regression for different SKUs or different brands or different kinds of combinations. So let's handle this problem in R. Let's load the libraries, deplet id R and fur. Then you just set working directory, load library reader R, then load your sample data. And now comes the most important part. You have to make a function. Now, how do you make a function over here? Let's understand this. If you look at this grouped regression model function, what I have done is I will pass it x. Now this x will be essentially a grouped data, and in the group data I will have a dependent variable and an independent variable. So I'll just use the lm command for it. I will make a variable called model param to capture the coefficients, and using these two guys, model def and model param, I will calculate the intercept column, the slope column, p-value column, r-squared column and adjusted r-squared column. Now this will go inside my original data frame. Now this will be for all the groups, right? So every group will have a different intercept, different slope, different p-value, different r-square and different adjusted r-square. So let's try to look at how this works. So let's just run this function. Now we'll have to do a bit of smart thing over here. We will nest our data dependent upon the groupings. So over here the grouping is on gender and country. That's why I have used group by gender and country and then nest. So let's just nest the data and look at how this looks like. Let's observe this. So over here you can see there are 6 groups: gender, country, and there's a data column. What is this data column? You can see this is a funny kind of a 2 variables and kind of this diagram icon thing. So let's just load one of them and see what it is. So you see the independent variable and dependent variable are essentially packaged in a separate data frame inside this nested data frame, which will make a lot of sense because what we will do is we will pass these guys inside that function which we have created, this grouped regression model. And when you pass these guys will have a column called independent variable and dependent variable. So what we will do is we will just do the model def for that, model param for that, and make these 5 columns and then return this data frame. And as we have nested it, so this will do for all the nested guys over here, the 6 groups, and it will essentially change the data frame, the nested data frame. So let's just look at how this works. So now you can just go to this data group and see that there are 8 variables now here inside. So let's just look at one of them. So you see intercept, slope, p-value, r square and adjusted r square. So what we have done is we have just removed the independent variable and dependent variable and replaced them with intercept, slope, p-value, r squared and adjusted r square. Right? Now if we unnest and ungroup them, you will get the intercept, slope, p-value, r square, adjusted r square for all the kinds of data which we have. So let's just do that. Let's look at this data frame. So you see gender, country, intercept, slope, p-value, r square, adjusted r square. So essentially, if we have to give the output of our analysis, nobody is interested in looking at the independent variable, dependent variable, because that is like not very easy to understand thing. That is why we're just resorting to the summary of the groups, the intercept, the slope, p-value, r squared and adjusted r squared. Now over here, luckily you see the p-values are significant and even the r square and adjusted r square are quite good. Now there's nothing very great about it. I have just made the synthetic data. So this is the made up data. So obviously, bit of disclaimer, there is nothing about the country and gender about these data. This is just a fictional data. I don't want to propagate any kind of relationship between gender and country on this data, because also you see the data set which I have, it's just independent variable, dependent variable. I have not even said what is this independent variable, dependent variable. So it could be anything, and let's say it's just a fictional data. So don't take it like in any other way. This is just for knowledge and just to understand how do you do regression by groups. And if you found this useful, do give it a thumbs up and do not forget to subscribe if you're new to this channel, because in this channel you can find content related to R, Python, data science, finance, Julia, economics and knowledge of any kind.